Keeping your brain young is a science. Aging happens because of oxidation. Think of wrinkly skin. Nowhere is there more oxidation activity than the brain because the brain uses more energy than any other organ and generates more oxidants. There are 7 key antioxidants which together recycle each other. These are vitamin C, vitamin E, glutathione, anthocyanins, coenzyme Q10, and alpha lipoic acid. There's a second line of defense involving B vitamins and minerals such as selenium and zinc. In this podcast, I'll be talking with the antioxidant expert, Associate Professor David Vauzour from the University of East Anglia, Dr. Filip Van Hulle, a leading expert in coenzyme Q10, and brilliant analytical chemist, Dr. Konrad Kowalski, who is a scholar at the University of Gdansk and runs the MassDiag laboratory. And he's developed a simple test to find out how your brain is aging and your body and what to do about it. What anti-ages your brain also anti-ages your body. So do listen to this podcast to add both years to your life and life to your years. So, Associate Professor David Vauzour, what is aging and how does this happen in the brain?
So aging is a complex biological process that involves gradual changes in the structure and function of an organism over the time. In the brain specifically, it encompasses a range of biological processes that contribute to change in the brain structure and function. So in particular, for example, you may have neuronal loss, where you have loss of your neurons, synaptic decline, which is a reduction of number of function of the synapses, a connection between the neurons, but also neuroinflammation and accumulation of neurotoxic proteins like amyloid beta or tau, which are representative of Alzheimer's disease progression, but also oxidative stress and mitochondrial dysfunction.
And why is the brain particularly so susceptible to aging?
Well, the brain is very demanding on energy, most metabolically active organ, really. Consuming about 20% of our body energy, despite only contributing or being actually 2% of our total body weight. It has a high lipid content and susceptible to oxidative stress. For example, DHA, which is enriched in our membrane, could be oxidized through free radical formations. But you have also limited regenerative capacity. So for example, limited neurogenesis. As we're getting older, the quantity of neurons which are producing is reducing over time. And then neural networks as well, synapses and function could be altered during the aging process.
So we're really talking about a brain very, very rich in fats. Omega-3 DHA particularly is concentrated in the brain, very, very prone to oxidation. So that's, part of the issue in relation to the brain. And also you talk about neuronal, that is, brain cells reducing in number and function, and the synapses, that's the space between neurons, and the buildup of amyloid plaque deposits and p-tau, which is related to tangles of those nerves. Now, so are these part of the aging process? Do you think, are they a sort of, not a side effect, but it's a bit like when your joints get old, you get deposits in the joints and osteophytes and so on. Do we think the amyloid plaque is the cause, or are they the consequence of a number of things that lead to aging?
That's a very interesting question. Well, the buildup of amyloid plaque and neurofibrillary tangles, normally composed of phosphorylated tau, as you mentioned, is normally considered as part of the aging process, particularly in the context of neurodegenerative disorders such as Alzheimer's disease. However, their presence and extent can vary among individuals and do not necessarily correlate with normal aging.
And is the brain shrinkage a bit like the body, where we lose height and the skin loses wrinkling? Is that sort of a similar process? Our brains literally start to shrink as we get older?
Well, the shrinking is actually done through different mechanisms, including neuronal loss, synaptic decline, as I mentioned before, neuroinflammation. It has an impact, obviously, on your memory. You have a reduced processing speed as well, and impaired executive functioning. The shrinking of your skin is also part of the normal aging process, but is actually using different mechanisms which are not directly related to the brain.
Yeah, I understood that the brain, if you're sort of over 70 or 80, is shrinking maybe at a total brain mass of maybe 1% a year. And in mild cognitive impairment or pre-dementia, it's more like 1.5%. And in Alzheimer's, it's more like 2.5%. Is that correct?
It is correct, yes, indeed. Yeah, we have more shrinkage in the Alzheimer's disease participant, or MCI, as you're progressing from, I would say, subjective cognitive impairment to mild cognitive impairment. The amount of shrinkage is actually increased in the brain.
And what is an antioxidant and what does it do?
Well, an antioxidant is a molecule or a substance that can slow the damage caused by free radicals, so these toxic substances produced by aging process. And it may be produced, actually, for example, free radicals could be produced by the pollution, external factors, cigarette smoking, for example. And they're normally very good at chelating. So antioxidant can chelate those free radicals. They're going to do that through electron donation, for example. They're going to transfer electrons to remove the free radicals. But also we have enzymes in our body, like the superoxide dismutase or the glutathione peroxidase, which are able actually to help removing those free radicals. And as you mentioned before as well, we have vitamins, vitamin C and vitamin E as well in high concentration, which can act directly through free radicals scavenging. Now, these are all internal antioxidants, but you can also have antioxidant coming from your diet, such as the polyphenols, for example. These are substances and pigments you find in fruit and vegetables, which give the range of colors, but also carotenoids or other type of phytochemicals you find in food.
So you've mentioned vitamin C, you've mentioned vitamin E, you've mentioned those superoxide enzymes and glutathione, and I think selenium is involved there, and also zinc and some other minerals. So Konrad, just looking a little bit closer up on glutathione, which I know has been an area of your research. One of the hottest areas of anti-aging science right now is how glutathione recycles vitamin C and vitamin C recycles glutathione. And I think that vitamin C is kind of a bit external, it's in your bloodstream, we eat it and so on. And glutathione is very much, within cells. So I'd like to just sort of explore that area. What is glutathione and why is it so important?
Glutathione is one of the main radical scavengers in our body. From chemical point of view, is tripeptide, and its location is, as you mentioned, is internally. So it's within the cells, not externally. So glutathione is not excreted by the cells. It is working inside the cells. So all free radicals that enter the cell, for example, also nerve cell, it's subjected to the action of the glutathione. And the glutathione as a compound, it have very complicated pathway, but in case of synthesis or production, but also it have multiple function. So it could help to prevent oxidation in our body or prevent the free radical action in our body on the multiple levels.
Now, as a nutritional therapist, one of our absolute keystone biochemical analyses to look at antioxidant status, to put it like that, it's always been red cell glutathione. But after following your research, Food for the Brain, the charity, are measuring the glutathione index, which is the ratio between the fully loaded glutathione, technically called GSH, and the spent or oxidized glutathione, GSSG. So what is this about, and why is it important to look at this ratio?
So starting from the beginning, so let me talk a little bit about the purpose of measuring and how we measuring glutathione itself. So glutathione, because it's very active substance, it's very hard to measure because it's subjected quite easily for oxidation. So that is why most of tests that are available on the market, they often don't give exactly the same value, because when you collect the blood, the glutathione, so collection the blood into the blood tube cause the stress to your red blood cells. So they start to use the glutathione to prevent this stress. So during the storage of the liquid blood, when you collect it in the collection part, then during the storage and during transfer of the blood, the concentration of the oxidized glutathione start to rise. So this is one of the main causes that analytical problem with measuring accurate glutathione index, because this glutathione index increase over time in the storage, and so the result of the analytical test do not show you exactly how it was when the blood was collected. So this is the reason why we develop on MassDiag the new glutathione index test. So our purpose is to, so our goal was to block the possibility of the glutathione to oxidize, so to oxidize to the GSSG as fast as possible, and we managed to do this thanks that we could quite accurate assess the glutathione index, so ratio between oxidized and reduced in the sample, the same as it was in the body when the sample was collected. And the glutathione index itself is a crucial, because it's crucial to measure not only glutathione in reduced form or in total concentration, but especially the ratio between those two, because the ratio between those two is showing not only the capacity of the organism to prevent free radicals, but also says how effective organism is to recycle glutathione in his own cycle. So how potent your body is to prevent any oxidative stress that occurs during your lifetime.
So I know you spent a lot of time absolutely getting this dry blood spot target, that the minute the blood hits, it's absolutely fixed and there is no oxidation after the sample is taken. And I think what also is being said here, understandably, is not all glutathione measurements are completely accurate, because it's just such a tricky beast. But I think you've solved that. But the second and really important point in relation to the brain is there evidence that as a person develops cognitive impairment and dementia, Alzheimer's, et cetera, that we get this change in the glutathione index, in the sense that there's less active glutathione, more oxidized glutathione, and less ability to recycle and reload that glutathione?
Yes, it is. It is a lot of this kind of information and this kind of proof in the scientific literature. So first of all, in case of the mild MCI, what we observe is two processes: not only decrease in total glutathione concentration in the body, so in the body where we could measure it, so of course in the red blood cells, but also the increasing concentration, so increasing concentration of oxidized glutathione. So then at the same time, so we have the decrease of the glutathione and decrease of the glutathione index. And the changes are dramatic with the mild cognitive impairment, because we are talking about few times higher, a few times lower glutathione index in this kind of diseases.
And one question for you, but also, David, Filip as well. So what we basically have is a very, very clear mechanism here of the central antioxidant process involving glutathione. We have a mechanism by which, as that really slows down and gunks up, it's clearly associated with cognitive decline. And then, as in science, we've got association, we've got mechanism, and we want to say, is it really causal? It's a very hard thing to prove, but in essence, do you think, and any of you, that this process of losing that glutathione capacity is actually causal in the process of neuronal degeneration and cognitive decline? David, what do you think? Yeah, Konrad.
David. No, maybe David he's an expert in the brain, and I will comment his comment.
Are we just looking at a nice marker, or are we actually getting quite close to a fundamental mechanism that is part of this aging process?
Yeah, it could be actually. In fact, the reduction in the antioxidant capacity from our brain, essentially through the regulation of the antioxidant response element of the gene, which is going to produce these enzymes like glutathione peroxidase or glutathione in general. So then you get that level going down as you get aging. So you have less protection from glutathione and the recycling between vitamin C and the glutathione itself. So it's a possibility that indeed reduced concentration of glutathione in the brain might be also a marker of brain aging.
And although we talk about glutathione as being, Filip, what would you like to say?
So what I think it's very interesting what I come to hear here about the glutathione, and I think actually same thing is happening with coenzyme Q10. So as we age, so there's also something like the ubiquinol ratio. So you actually have two forms of coenzyme Q10. You have the reduced one, or the active one, or the fully loaded one, as you want to call it, the ubiquinol, and then you have the oxidized one. And here also, as we age, the concentration of the reduced one is going down. It's actually very similar to glutathione. I also come to hear, I also heard here earlier that it's very complicated to measure glutathione. Same thing is actually the case with ubiquinol. And so ubiquinol is also a very active antioxidant. And if you take it from the blood, and you want to measure it, it will immediately start to oxidize, and you will get the oxidized one. So very complicated to measure. Sometimes they have to use complicated systems as HPLC to see which one is oxidized, what one is not oxidized. So I think it's the story of the more getting oxidized as we age. You can see that with different nutrients. And I think in case of coenzyme Q10, yes. In case of glutathione, yes. So it looks like the antioxidant capacity is getting lower as we age. So I think this is the right way how it goes.
So and also both glutathione and coenzyme Q, as I understand, are synthesized in the body, and what we eat can also deliver coenzyme Q and can deliver glutathione, or potentially its sort of precursor amino acids like N-acetylcysteine. So maybe starting with glutathione, are there any particular foods that would increase our ability to produce glutathione?
So first of all, the glutathione is very, as I said earlier, is quite sensitive compound. So the supplementation of the glutathione itself, it's not from a nutrition point of view, it's not effective at all. So what we could do, we could deliver to our body the building blocks to let our organism to produce glutathione within the cells. And the glutathione, is, as I mentioned earlier, is a tripeptide. So it's consisting from the 3 crucial amino acids: glutamate, cysteine, and glycine. And glutamine itself, it's very abundant in the organism, so it is not crucial amino acids for this process because it's everywhere, and the erythrocytes are actually full of glutamate. So then the crucial amino acids is the cysteine and the glycine. The problem with the glycine in context of the nutrition is this is not very abundant. It's of course present in the meat, but it's not very abundant in some, let's say, steak, because to deliver efficiently the glycine to the organism, we have to consume the proteins that are consisting in quite a high percentage with the glycine. And the problem with delivering this kind of food is like we stopped to eat this kind of meat because the glycine is one of the main building block of collagen. And to deliver efficiently glycine to our body, we have to eat more collagen. So we have to consume some, broth, for example, that was made from the, chicken skin, chicken bones, chicken legs, something like that.
Now, I know that many people, myself actually included, supplement trimethylglycine. It's a source of glycine, and also of tremendous interest is N-acetylcysteine.
Yeah.
And so you may know that N-acetylcysteine, interestingly, in America has just become sort of illegalized as a supplement. And this was a consequence because the substance is either classified as a food or it's classified as a medicine. And the decision has been made to classify N-acetylcysteine as a medicine because there's evidence of its tremendous effect, and therefore it's no longer available in America to buy as a supplement, not because there's anything wrong with it. So tell us a little bit about N-acetylcysteine in relation to glutathione.
So N-acetylcysteine is simply more bioavailable version of the cysteine. So third building block of the glutamine and most restrictive one. So organism, like, it's one of those 3 amino acids where the supplementation is crucial. N-acetylcysteine is of course banned in the US, but because it's simple, it's not connected with its potent activity in case of supplementation and in case of brain function, but because of the history problems, because it was registered as a drug in, I think, 1960s for intoxication of, I think, paracetamol or some other medicine, and in 80s it started to be medicine for problem with lungs, and that was the cause and why it's classified as a drug. And now the FDA have quite a big problem with this, but I heard that it's still somewhere available on the market. So,
and if you supplement N-acetylcysteine, will you get a measurable increase in glutathione?
Yes, but you have to think about supplementing. It's first of all supplementing an acetylcysteine. It will be more efficient and of course cheaper, more cost-effective way to supplementing compared to glutathione. So it's cheaper supplement and it is effective, but still bioavailability of the N-acetylcysteine is not such a big we are talking about less than 10% of the N-acetylcysteine that was consumed in the supplement form is absorbed by our intestines and transferred to the bloodstream. But still, even with limited bioavailability, there is it is very strong evidence that it helps to not only increase the concentration of the glutathione, but also improve the glutathione index.
Now, one thing I remember reading some time ago, Professor Treusch from Germany, I don't know if you ever came across this, but he actually achieved a patent to do with his research on the combination of anthocyanins or anthocyanidins, that's the blue-red pigment, the polyphenol that David was referring to, that it recycled glutathione so effectively that in effect it increased the potency of the glutathione several times. And he did research that enabled him to get a patent on that. And logically, that got me thinking that if I do supplement either glutathione or more likely N-acetylcysteine, I want to do it with anthocyanidins to just sort of, if anything gets oxidized, it gets recycled again. Does that make sense?
It could be very similar mechanism as the function of the vitamin C in the recycle of the glutathione, because vitamin C, it's not directly, so in this case anthocyanins could work in similar way. So vitamin C that is working more extracellular, it has its role in the recycling of the glutathione, but it's not direct role. So the role of the vitamin C is to prevent action of the free radicals instead of the glutathione, and then let the glutathione recycle itself. So anthocyans could work in very similar way. So because of their potency in the as a free radical scavengers, they could also, make some work, that was usually dedicated to the glutathione, and then the glutathione could recycle itself more effectively, and then you could increase the glutathione index and also the glutathione concentration.
So really, we've got team players, glutathione, vitamin C, anthocyanidins, and coenzyme Q, or ubiquinol, which is the name of the fully loaded reduced coenzyme Q. Yes, so Filip, are there foods that we can eat, and what is the effect if we supplement ubiquinol? What sort of dose, what sort of benefits, and if it ties in with anything about glutathione and so on, be very interesting to know. And David, do feel free to jump in at any time you like as well.
Good. Well, yeah, I think so. Coenzyme Q10 ubiquinol is a substance that is available in all kinds of food. Typically, it has a very high concentration in the heart. Actually, originally, when it was developed, it was only available as an extraction product from bovine heart, because there you had the highest concentration of coenzyme Q10/ubiquinol. But today, if you want to take ubiquinol so it's a body-owned substance, so you make it inside your body. But as we age, the concentration goes down, and there is a need actually to refill, so to take it. But a good dose, for instance, is 100 milligram. And if you want to take 100 milligram ubiquinol, I have it here in front of me. So what should you eat? So 100 milligram ubiquinol, you can find it in 120 cans of sardines, or 60 avocados, or 3.5 kilogram fresh beef meat, or 33 tablespoons olive oil. So I think you can easily see that these numbers are way too high. It's much easier to take it in a small capsule. Yeah, so this is where you can find it. Yeah.
And what is the effect of supplementing 100
Yeah.
milligrams of ubiquinol? And also, do we know yet, would we expect it to improve this glutathione index? I'm not quite sure where the ubiquinol fits into the team players we've spoken about: vitamin E, vitamin C, glutathione, and acetylcysteine.
Yes, I think so. Basically, ubiquinol has three basic functions. One, it is working inside the mitochondria. So it is really crucial in the electron transfer inside the mitochondria. So it will really help to make ATP. So this is what it's doing.
Which is cellular energy.
Right, yes. But on top of that, which is very interesting, is that it is a fat-soluble antioxidant. So during the production of ATP, during the production of energy, you always have a lot of waste. You can say free radicals which are produced, and ubiquinol helps actually to
disarm.
How to say, to disarm, yeah, that is the right word, to disarm the free radicals. So these two things, but it actually has a third action, which is something that was found only a couple of years ago by the university in Cordoba, is that ubiquinol also helps to make more mitochondria. So if you take ubiquinol in the dose of 100, 200 milligram a day, it will help you to make more healthy new mitochondria.
And these mitochondria are they're the powerhouses. They're the energy factories within all our cells, of which we have billions of them, maybe even trillions. I'm not sure how many mitochondria we have. So you're literally, you're making more energy factories, and you're allowing those energy factories to deal much more effectively with the exhaust fumes, which would then be using up glutathione as a primary defense mechanism, which is spared by having more vitamin C. So you're kind of describing my daily routine, because I have an antioxidant. I supplement N-acetylcysteine, anthocyanins, vitamin C, coenzyme Q, and vitamin E, plus eating as many foods as I can in that way.
Yes, yeah. And on top of that, there may be some possible interaction, I think, between ubiquinol and glutathione. So what we actually found is that if you have the oxidized form of coenzyme Q10, and to convert that into ubiquinol, the fully loaded form of coenzyme Q10, this can be done under the influence of different enzymes. And one of them is the glutathione reductase. So this means actually, if you take, or at least this means to me, if you take immediately ubiquinol and the direct active form of coenzyme Q10, it will have a kind of sparing effect on your glutathione reductase. So I think the more advanced, the more powerful nutrients you can take, it will have like a protective action on other nutrients that may be available somewhere in your body.
And the wonderful thing about this, of course, is now we have this glutathione index, and it's a very stable test. We can start to look at exactly what happens to that with ubiquinol 100 milligram supplementation. Now, there's one key player that has not been mentioned, and I would just like to open this up to all of you, and that is that glutathione and vitamin C, to an extent, is helped in its recycling by something called NADPH, which ultimately is derived from vitamin B3, niacin, or nicotinic acid. There's a lot of talk out there. For example, David Sinclair takes something called NMN, nicotinamide mononucleotide, to boost NAD. Some people supplement forms of NAD, again, ultimately made from niacin. Maybe David, what's your take on this approach to anti-aging?
Not so sure. Difficult question. I mean, I know well the work of David Sinclair. I can't really say whether it's the good approach to use. It might work with him or some with people, but I'm not sure it's going to work with everybody else. I don't know. I mean, difficult question to really answer. Taking the supplements. I mean, I'm always very cautious with supplements because I believe more in food rather than just supplements. People tend to take supplements and sometimes they take supplements to higher dose, which become toxic at some point as well. So I would say rather than taking supplements, maybe try and find food. But as Filip mentioned, I mean, some of these supplements should be taken because otherwise you will need to eat a hell of a lot of food to get that level you need. So yeah, that would be my answer.
Okay, and one of the interesting things, because my view has been a little bit skeptical in the sense that the precursor is niacin vitamin B3. And I got really interested. My background is in psychology and originally in schizophrenia. And I came across this double-blind controlled trial giving very high dose of niacin to people with schizophrenia. And the results were remarkable. And I didn't know at the time, but it was Dr. Abram Hoffer, who was the head of psychiatric research in Canada, and he was it was the first ever double-blind controlled trial in psychiatry. So I jumped on a plane and I went to meet him, a lovely man, and I said, "How many people have you treated with this megavitamin approach?" And he said, "About 3,000." And I said, "What is your success rate?" And he said, 85% cure. And I said, "Well, you need to define cure because I've never seen a cured schizophrenic." And he said, "I have three definitions. One, free of symptoms. Two, able to socialize with family and friends. And three, paying income tax." I'd never seen a schizophrenic paying income tax. So I actually became his student. But the interesting thing is that there was a side effect of this niacin treatment for schizophrenia. And by the way, it's not so crazy because if you're really deficient in niacin, it's called pellagra. And pellagra has the 3 Ds, which is dementia, diarrhea, and dermatitis. So in other words, you go crazy if you have no niacin. So the logic here was maybe some people have schizophrenia just need a lot more of the very same nutrient that stops you going crazy. That was the logic of it. But the side effect of this high-dose niacin, he was using 2 grams of niacin, 2,000 milligrams, was that cholesterol came down. And the reason I'm mentioning this is that coenzyme Q got a lot of attention in being highly effective in mitigating the fatigue, and particularly the muscle fatigue effects from statins when lowering cholesterol. And of course, cholesterol, 25% of cholesterol is in the brain. So any comments about that? Filip, you may have a view about CoQ, statins, cholesterol, and fatigue.
Yeah, I think so. Actually, very interesting. There is a direct link between statins and coenzyme Q10. So if you have a statin, so it will actually block your HMG CO enzyme, coenzyme A reductase. So it will block that enzyme, which is responsible to make cholesterol inside the body. Now, the downside is that the same enzyme is also responsible for your body own production of ubiquinol. So if you take that, it will also reduce your body own production of ubiquinol. And so actually what is happening is statin patients, the longer or the heavier statin they take, the more they will get myopathy. And this is something which has been found. So like a muscle pain. It's a kind of, I think you can
myopathy is myo is the muscles and pathy is is pathological. So right. Myopathy induced by statins is basically muscle pain, muscle ache, muscle tiredness.
Yes, right. Yes, yeah. And so actually very interesting is that a big pharmaceutical company used to have even a patent on the combination of statin and coenzyme Q10. So they had a patent and they blocked the market for a very long time because they did not want that anybody was spreading the news that statins caused a coenzyme Q10 deficiency.
So what you're saying, and there are 2 types of statins, aren't there? There are lipophilic statins and other statins, but are you saying that any statin is going to inhibit the production of coenzyme Q, and consequently, really anyone on a statin should be supplementing ubiquinol 100 milligram or so?
Yes, it doesn't matter which one, whether it is the fat or the water soluble statins, because it will always block that specific enzyme. But of course, some may be blocked stronger than others.
Now, I want to, sorry, please.
Sorry, yeah.
No, I'd like to talk about anti-nutrients, so the other side of it. But before doing so, especially with David, who is a Frenchman, I actually spent my youth brought up in the south of France, in Provence, eating the delicious peaches and aubergines and courgettes. And my ratatouille is exceptionally good for an Englishman. So I just want to ask you, this isn't science, this is obviously opinion, but you're three very informed men. What do you supplement, if you do? And where do you focus your attention in terms of what you eat? So maybe starting with Konrad, what's your take?
I was working many years on the vitamin D and on the vitamin D deficiency topic, and I'm feeling myself as an expert in vitamin D especially. So right now I'm supplementing vitamin D. Of course, I have my own scheme of supplementing this nutrient to maintain quite high concentration, above 40 nanograms per ml. Also because I have Hashimoto thyroiditis, so I have problem with my thyroids, and I'm also supplementing the magnesium for just before a sleep to improve my quality of sleep.
And how much vitamin D do you supplement? And that 40 nanograms per mil, that's 120 nanomoles per liter in the UK measure, isn't it? I think.
Yeah.
So.
Something like that. So recommendation in Poland, where I'm from, is maximum 2000 IU per day. And I also made a lot of studies on high doses, supplementation of the high doses of the vitamin D. So I have my own scheme where I am taking high dose once for a while, for example, once a month, and then before these high doses, I am filling the rest of the days with some small doses like 2000.
Okay, and what is your high dose, your monthly dose?
What is my high dose in the single shot?
Yeah.
200,000 units in
200,000 units, yes, because vitamin D does store. And how much magnesium do you take?
I don't remember. Sorry, that's my
it's okay.
That's my wife expertise.
Okay. Yeah, magnesium is a very interesting one. And vitamin C, do you supplement vitamin C out of interest?
Once a while, but not in the day by day shape.
And how about you, David? And also, which foods do you really like to focus on?
Well, I don't really supplement. I mean, from time to time I'm taking magnesium essentially when I'm doing a lot of exercise and I feel that the muscle is a bit tired, so I'm taking magnesium and it helps. But normally, I mean, I'm more like, as you mentioned, as a French guy, I'm more like focusing on the food itself. So food, well, ratatouille is a good start, but I'm trying to eat actually as balanced as possible. Having the rainbow of colors in my plate. Sleep quality as well, trying to sleep at least 7 to 8 hours a night. Bit of exercise, classical, I would say, lifestyle, in order to maintain your capacity to the maximum.
And do you focus on berries? Because they're, of course, very rich in anthocyanins.
I do, yeah, from time to time, yeah. I mean, essentially the blueberries, but also blackberries, which are very rich. From time to time, cranberries as well, which helps as well with a urinary tract infection, for example. But also, as we demonstrated, are able to improve your cognitive performance and to improve your blood flow across the brain. So yeah, some berries from time to time, which contain the anthocyanins you were mentioning before.
Yeah. And Konrad would like to make a point.
Yeah, I want to make a point about the blueberries, because when you consume blueberries, you have to remember that the efficiency of the bioavailability of the anthocyanins is connected also with co-consuming blueberries, for example, with banana. So it's very strong suggestion to do not make the smoothie that have blueberries and banana in the same mixture, because the banana contain the enzyme that inactivate the antioxidant capacity of the blueberries.
Ah,
So
that's
this
very
is-
interesting. Yeah, because there are many smoothies that have blueberry
Yeah.
and banana. Yeah, and that's got David. David, yes. What do you want to say?
Yeah, thank you for mentioning this. Yeah, there was a recent paper from the University of Reading on this. Indeed, actually, they were showing that banana contain a high concentration of the polyphenol oxidase, which is going to, in fact, oxidize all the good stuff from your other berries or other polyphenol-rich diet, fruit and vegetables. So whenever you're doing a smoothie, indeed, avoid putting a banana inside, which is going to basically kill all the benefits you're taking.
Interesting. And Filip, what do you supplement? What's your food focus as well?
Yeah, so well, of course, I start always with vitamin C, and the dose I take vitamin C, people maybe will say it's very high, but I take usually between 2 to 3 grams a day. This is where I start. Then, of course, I take ubiquinol. Ubiquinol, I take every day at least 100 milligram, but then depending on what kind of busy or stressful day, I may go up to 300 milligram a day. Then I take omega-3, so it can be fish oil, it can be krill oil, depending a little bit what I have. I take also very often B vitamin complex. I take magnesium every evening. So dose is 100 to 200 milligram in the evening. And then if I see that many people are sick around me, then I will add some zinc. And then during autumn, winter time, I may take some vitamin D. This is a little bit the supplements and probiotics if I have like some intestinal problems. So I'm actually a supplement user, because I like very much healthy food. Also, I like ratatouille, but I know that it's impossible to take some of the key nutrients just from food. So you have to take them as a supplement.
Well, yeah, I mean, I do pretty much what you do with a few extras as well. I was a student of Linus Pauling, and he just considered that we are the defective ape, having lost that GOLO enzyme capacity to make vitamin C. So his logic was, having studied animals that make vitamin C, that have much less susceptibility to viral diseases, cancer, heart disease, and various other things, was how much do I need to take to get my blood level to effectively the same as a goat, as an example. And that got him to 2 grams, I think, at the end of his life, more like 6 grams. I take 2 grams every day. Also stress, when under stress, I will increase my vitamin C level. If I get any sign of a cold or infection, I instantly up my dose to pretty much 1 gram an hour. And I know I had 2 rounds of COVID, which took about 18 hours to get over. And the vitamin C I take has also in it zinc and anthocyanins. So yeah, magnesium I find fascinating. But I'll tell you something interesting, because actually in 2 weekends' time, we've invited over a guy called Dan Kittredge, and he runs the Bionutrient Research Institute in America, and has analyzed more plants and foods, not just plants, also meat, than any place I know. And he is reporting for example, a 40-fold variation in antioxidant levels in carrots. And it doesn't matter if they're organic or biodynamic or bought in a supermarket or bought in a farm. So he's actually, he's analyzed oranges that have no vitamin C at all. So I actually grow all my own food pretty much now in Wales. And I asked him what predicts the nutrient density of a food. And he said the only single measure so far that has done this is the respiration of the soil. Now, this might be right up David Vauzour's street, because basically, if soil is full of fungi and bacteria and mycorrhizae and organisms, they are metabolizing, they are generating energy, just like we were talking about in mitochondria. They're generating energy. They need antioxidants as well for the exhaust fumes. And as a consequence, they're literally breathing, exhaling, and you can literally measure that respiration of the soil. In other words, the conditions of life are enough for the soil to be full of life. And that is the only measure they've found so far that actually predicts the nutrient density of food. So that kind of brings us to the microbiome of the soil, but also the microbiome of the body. David.
Yeah, you're absolutely right. Actually, there's a concept called One Health. I don't know whether you came across this, which looks at the impact of, the soil, the microbiota from the soil and how that is affecting plants. And whenever we're eating that microbiome as well, how that is going to affect us, our own microbiome, our bugs in our gut, but also the one from the animals. So this concept of One Health is looking in general at the impact of the whole environment around us, which we kind of call the exposome as well. So it's a very important aspect, indeed, that plants have the right microbiome surrounding the roots, essentially, because not so much in the leaves, but in the roots, essentially, to provide the nutrients to the plant. That's a good starting point.
Fascinating. We could do a whole podcast on just this, and maybe we will at some point. Now, one thing I want to ask is, we talk about all these fantastic antioxidants and aging and the brain and so on. So what about smoking? Because one puff of smoke is 1 trillion oxidants. Is the effect of smoking to annihilate all this beneficial food, vitamin C, coenzyme Q, biquinol, etc.? How bad is smoking from the point of view of anti-aging the brain, oxidation, and so on? And can you mitigate the effects of smoking? Anyone like to comment on that?
Of course, smoking is, terrible, have a terrible effect on the organism itself. Glutathione itself could mitigate a little bit the effect of the smoking on 2 different levels. First of all, on the antioxidant level, but also in case of the removing the toxin that are entering the body through the cigarette smoke. So if you maintain your glutathione index high, then the possibility of minimalizing negative effect of smoking could be one of the issue, one of the solutions. But nevertheless, like smoking, it's terrible thing for your body.
So it will be interesting to see the effect of smoking on the glutathione index. And yeah, David, what's your take?
Yeah, well, we know that smoking is bad for us. I mean, when it comes to the brain, it's increasing oxidative stress and inflammation. It shows as well that smokers are at higher risk of cognitive decline, including memory loss. It shows as well structural changes in the brain. And you have a reduced blood flow as well, which is going to affect the perfusion across the brain, so of your blood. So all of these are an impact, and also is impacting on your neurotransmitters. So nicotine and chemicals in tobacco can actually balance the neurotransmitter in the brain, affecting mood and behavior and the cognitive function. So that's not a good thing in general.
And what about vaping?
That's another one. I think it's early days, but there are some papers coming out now showing that it's not better, essentially, because most of the actual flavors they put in is actually glycerol in order to maintain it into a viscous solution. And glycerol is actually inhaled, and that's not good. I mean, glycerol, we have to remember it's used actually as an antifreeze in your car. So maybe it's not a good idea to inhale this kind of things.
Now, one thing that's interesting on pollution, which obviously smoking and pollution are the anti-nutrients. I read a very good study that said pollution increases risk for dementia, but not if your homocysteine level was low. Homocysteine is a measure of methylation. I feel bad that we haven't mentioned B vitamins because they're also important antioxidants, and this methylation process is so vital. And I also remember studies on that smokers had a much higher homocysteine level. And in this particular study, they either reduced, I think, to like 5 a day or much less than 20 a day, or nothing. And the reducing to 5 a day didn't actually lower the homocysteine, but the stopping smoking tremendously lowered homocysteine. So, yeah, David, what about methylation and its role in antioxidation and protection from things like smoking, pollution, and so on?
You mean methylation as the epigenetic factor, or methylation?
I mean, yeah, B6, folate, B12, lowering homocysteine, improving the ability to turn that methionine in our food into SAMe, S-adenosylmethionine, as opposed to homocysteine.
Well, I'm not an expert on this, to be honest, so I can't really comment on this. Maybe some of my colleagues here have a better idea on this. I don't know much about this system, the complex system.
Yeah, it's very interesting because I remember talking to Professor Bill Harris in one of our previous conversations, an expert on omega-3, and he invented the omega-3 index, which is a fantastic red blood cell test. And I said, do you get people with the same intake of seafood, but with different omega-3 index? And he said, yes. And what we've learned is you need the B vitamins, you need methylation to actually effectively incorporate the omega-3 into the membrane. So, you know, we've spoken about the classic antioxidants, glutathione, vitamin C, and anthocyanins, and then the role of coenzyme Q, and each is saving the other and working as team players. But, you know, around the corner, we have niacin. You know, we've mentioned that B vitamin already. We have these other methylating nutrients. The team gets a little bit bigger. And there is one we haven't mentioned, which maybe is worth throwing in here as well, which is alpha lipoic acid. Would anybody like to say anything about alpha lipoic acid? No comment. Okay. That's okay, but that's another antioxidant, isn't it? It's another key player. Filip, I think you know something. Could you just tell us a little bit about alpha lipoic acid to put it in this context?
Well, I think it's a very interesting component. So I think I have seen some clinical studies in the field of diabetes, if I remember well. But how it exactly interacts with the other nutrients, I don't know. What I know is that sometimes also earlier in the talk you mentioned about US market banning NAC, and I think now on European level they are trying to ban alpha lipoic acid as a dietary supplement. So sometimes authorities want to ban some substances. I don't know, based on certain rules or ideas they may have. But for the rest, yeah.
It's usually because they work. And
I think so, yeah.
And there's a drug market interest. And what got me interesting, and this also leads us pretty much to our final question, Bruce Ames, a scientist who I have a tremendous respect for. And it was really his triage theory of aging that in a sense that if we don't have the optimal supply of nutrients, the body will do what it can to survive in the moment, generate energy and so on, but at a cost. And that cost is aging. And he's done some fantastic work on lipoic acid. I actually supplement a combination of vitamin A, vitamin C, lipoic acid, glutathione, anthocyanins, bit of resveratrol in there, and coenzyme Q, so the package. But yeah, is there any reason why our brain should wear out before our body? That's my penultimate question. Do you think we can get to the end of our life with a functioning brain, even if we do get a bit more wrinkly?
If you ask me, I would say, why not? I mean, if the nutritional status inside your brain or inside your heart is very good, huh? So yeah, I think it's not a matter on living longer, but it's a matter of living healthier longer, huh? So having still the capability of doing everything you want, huh? I think this is important, and for that, according to me, you need to have a very good nutritional status, huh? So because we have a very active lifestyle, because there is the pollution, you need to supplement, you need to take certain supplements, and you need to eat as healthy as possible, meaning less processed food as much as possible.
So yeah, anybody else on the brain wearing out before the body? Or I can ask you another question, which is more like a straw poll bet. How long? Yeah, Konrad, you'd like to make a point.
Yeah, just a quick point. I think what we have to remember is like the blood-brain barrier is existing. So all compounds that we are exposing ourselves through our lifetime, they have to enter the brain. They have to go through the blood-brain barrier, and because of existing this barrier, then the exchange of this compound back when we are not exposed to them anymore, this is much slower compared to our bloodstream. So we have to be very, very careful what we are exposing for. We have to live healthier, eat good, do not expose ourselves for pollutants, for toxins, for pesticides, because the removal from our brain will be much, much slower than the removal from our bloodstream. So we have, and of course, certain compounds, because of their properties, especially lipophilicity, could stay there longer, that they could be removed from our bloodstream, but they could stay there.
It's a very good point, and I'm so glad that we talk both about anti-nutrients and nutrients and the barrier between the blood and the brain. Yeah, the interesting thing is Linus Pauling, twice Nobel Prize winner, 48 PhDs. I filmed him just before he died in his mid-90s, and Dr. Abram Hoffer was on my scientific advisory board, again in his mid-90s. He stopped seeing patients 2 weeks before his death. 4 days before his death, he said, "I'm not feeling very well." 2 days before, he checked into the local hospital and he didn't have any disease as such. And I really, really like that. But my sort of final interesting question to you, which is purely, guesswork or hypothesis. Filip wants to make a point before I ask you the final question. Yes, Filip.
Yeah, I wanted to comment on what Konrad told about the products going inside the brain. So we actually, a very interesting study that was done at the Tokyo University was with a very high dose of ubiquinol, so 1200 milligram ubiquinol during 36 months, a very long time. And what we actually saw is that initially the levels in the plasma of ubiquinol increased very high, and then it went down. But the levels of ubiquinol continued to increase inside the brain. So as mentioned earlier, so the brain needs a lot of energy. There's a lot of free radicals. There's also a very high, there's also a lot of cholesterol inside the brain. And ubiquinol is actually sitting on top of the cholesterol. It's actually protecting cholesterol against oxidation. And this may be the reason why ubiquinol is going so much inside the brain. So it looks like the brain is catching a lot of ubiquinol.
So that's also fascinating. My one point, by the way, one of the reasons I tend to be in favor of supplementation is simply that we do not eat enough. So when I look at, they found in Wales where I live, Homo sapiens, 40,000-year-old, and almost a quarter of their diet was marine food. But I estimate that they must have been expending 3 times the calories that we were. So in other words, they're eating a lot more. So whatever nutrients they got, in those days, was spread across 3 times as much food as I eat. So now I've got to get the same amount of nutrients from a third so much food. That's kind of one of my persuasions towards supplementation. So my final question, which is, how long do you think, if we did absolutely all the right things, if you had to guess, and we'll place a bet on it, how long do you think humans can live? I think the record was held by Madame Calmont, a French woman, at 120, but was recently exposed as a fraud. I don't know if you read that story in the paper. Her daughter had acquired her documents. So it seems that that particular one wasn't quite the case. I think we have Izumi in Okinawa, where I'll be going in November. Again, he hit about 120. Both Abraham Hoffer and Linus Pauling started quite late in their nutritional career. So yeah, if you just had to pick a number, there's no science on this, pick a number. How long do you think humans could really live if they maximize their nutrition, minimize their anti-nutrients, and did all the right healthy things? What do you think is our potential? Konrad, give us a number.
This is a tricky question, because what does it mean to live? If you mean like the example that you gave us, like the doctor who was working like up to 4 days before he died, that's a beautiful life. And I think for all, I'm wishing for all of us to have this kind of life, to be 100% present and 100% intellectually capable to our last days of life. And when I'm thinking about this kind of performance and this kind of life, I think 90 years old will be more than enough to live our life 90 years or 100 years with our full capacity. And also in case when we are looking on the perspective of the society itself, so 100 years, it's a huge amount of time in such a fast changing world that maybe in the future will be even more difficult for us to even if our intellectual capacity is at our full speed, to be on the pace with such a changing society and changing technology.
And what about you, David? What do you think is our absolute maximum potential if we do everything right?
Absolute maximum, I don't know. I mean, I would like, if possible, that people could live up to like 100 years or something. But again, as was mentioned by Konrad, the actual situation with pollutions and things might actually slow down maybe that aging process. Increase, sorry, that aging process. Yeah. So difficult to say. I mean, the most important is to live a long life, healthy life, and then maintaining our cognitive functioning as good as possible and be independent as much as possible. That's, I think, what everybody wants to have.
Good. And Filip?
Yeah, I think I would choose 120. I think 120 is a nice number. Of course, I agree with the other comments that it depends also quality of life. With 120, I mean really in full capacity of everything. So I think if we do the right things, I think 120 may be reachable.
Yeah, I would go along with that. I will leave you with a poem I wrote the other day, which is nature always provides a solution to help us with our evolution. Seems obvious to me we need vitamin C to combat excessive pollution. Anyway, we come to the end of this Anti-Age Your Brain podcast, and thank you very much, Associate Professor David Vauzour, Dr. Filip Van Hulle, and Dr. Konrad Kowalski for your brilliant research, insights, and education for us all. Thank you for joining this podcast.
Thank you.
Thank you.
Thank you.